Hi everyone! Today we're going to be talking about conditional statements and biconditional statements. Our objectives for today are that students will be able to analyze statements in if-then form, write converses, inverses, and contrapositives, and you'll be able to identify and use biconditional statements. Let's get started. When do we see conditional statements in the real world? Well, here's one example. So call centers route calls to the appropriate departments using menus that allow callers to choose from a number of options. The recorded directions are frequently in the form of conditional statements. For example, if you're calling a customer service line, they'll say, if you need help, then press 1. If you would like to hear your options, then press 2. I'm sure many of you guys have had phone calls like this or have listened to customer service lines telling you that, and this is a real example of use of conditional statements. Conditional statements. So a conditional statement is a statement that can be written in if-then form. So basically we say if something, then something else. The symbolic form for this looks like this. We write a P, an arrow, and a Q. And this is read as if P, then Q. Or we could say P implies Q. Alright, most of the time you'll hear me say if P, then Q. The hypothesis is the phrase that immediately follows the word if. And the conclusion is the phrase that immediately follows the word then. Here's an example of a conditional statement. We want to identify the hypothesis and the conclusion. So first let's start by identifying the hypothesis. The hypothesis of a conditional statement is the phrase that immediately follows the word if. So we've got our word if here. So our hypothesis would be if you live in Nashville. So we would write that our hypothesis is you live in Nashville. Our conclusion is this is the phrase that immediately follows the word then. So we've got our word then. So therefore our conclusion is you live in Tennessee. So we write that as our conclusion. You live in Tennessee. Oops. Pretty simple enough, all right? Hypothesis is what follows the word if, conclusion is what follows the word then. All right, so I want you guys to try number 3, identify the hypothesis and conclusion of this conditional statement. When you come back, I'll have the answer written on your screen for you. So go ahead and pause your video now. All right, so you should have gotten that the hypothesis is what immediately follows the word if. So your hypothesis is a quadrilateral is a square. Our conclusion is what immediately follows the word then. So our conclusion is it has 4 right angles. If you have any questions on this, please raise your hand, call me over so I can help you. Otherwise, let's move on. All right, now you may be given statements that are not in if-then form, and our goal is to write conditional statements from these statements. So for example, number 5, we want to write a conditional statement by changing the form or the way it's written. All right, so if we have the statement, all numbers divisible by 4 are also divisible by 2. What we want to try to do is break this statement apart so that we can write it in if-then form. So if we cut it in half, essentially, all numbers are divisible by 4 are also divisible by 2. We can say that if all numbers are divisible by 4, then they are also divisible by 2. So we're trying to break it apart into 2 somewhat separate statements so that we can rewrite it in if one thing, then the other, in that form. So if we were to formally write out this statement, all right, we would want to say if all numbers divisible or are divisible by 4, then they are also divisible by 2. And there's your statement. Number 7, we want to write this statement in if-then form. So the statement is Valentine's Day is in February. So if we were breaking it apart, we would say if it's Valentine's Day, then it's February. All right, because we're trying to break it into 2 parts. And if it's Valentine's Day, then it has to be February because Valentine's Day is on February 14th. So writing this as a conditional statement, we would say if it is, oops, let me get this on the line. If it is Valentine's Day, then it is February. And there's our statement. All right, we changed it from just being a standard statement and we put it in if-then form. We made it a conditional statement. All right, now we have several related conditional statements. We call them the inverse, converse, and contrapositive. So what we're doing is we're taking our original conditional statement and changing it slightly. So the inverse of a conditional statement is formed by negating the hypothesis and conclusion. So we're giving it a negative value. We're changing the truth value of the statement. All right, so how we would write this is we would say, oops, can't really see that. The symbolic form would be if not P, then not Q. All right, so we're using that little negation symbol, and we're saying if not P, then not Q. So we're negating both the P and the Q statement. The converse of a conditional statement is formed by switching the hypothesis and conclusion. All right, so the symbolic form for this would be if Q, then P. So we're just switching our P and Q statement. We're writing the Q statement first, then the P statement. And now the contrapositive of a conditional statement is formed by both negating and switching the hypothesis and conclusion. So it's formed by both negating and switching the hypothesis and conclusion. So the symbolic form for this would be if not Q, then not P. So we're both negating and switching our P and Q. All right, so example number 1, our directions are to write the inverse, converse, and contrapositive of the following conditional statement. We also want to determine the truth value of each of the inverse, converse, and contrapositive. And if it's false, remember we have to provide a counterexample. So let's start with number 1. It says, if it is Saturday, then there is no school. So the first thing we want to do is identify what is our P and what is our Q. So if it is Saturday, we're going to call that P, and that's our hypothesis, right? Because it follows the word if. Better P than that, okay? Then, so if it is Saturday, then there is no school. That's our conclusion, and we're going to call that statement Q. Now what we want to do is remember what is the symbolic form for inverse, converse, and contrapositive. So the symbolic form for inverse, if you remember, look back at your notes right above. For inverse, it's if not P, then not Q, because we are negating both P and Q. The symbolic form for converse is we switch them, so we say if Q, then P. And the symbolic form for contrapositive for both negating and switching would be if not Q, then not P. All right, now starting with our inverse. So we are negating both the P statement and the Q statement. So if we're looking here, if it is Saturday, in order to negate that, we would want to say if it is not Saturday. So we put the word not right here. So let's write that out. If it is not Saturday, oops, and let me put that on the line. All right, so that's the beginning of our inverse. Okay, then we want to negate our then statement, or our Q. So then there is no school. It already is negative, right? There is no school. So in order to negate it, we want it to have the opposite truth value. So to negate there is no school, we would say then there is school. So that's how we would negate our Q statement. We would change the truth value of it. So if it is not Saturday, then, let's see, I don't know why I did capital. No capital. Oh well. Then there is school. Done. All right? So now we wrote the inverse of the statement. If it is not Saturday, then there is school. Now, what is the truth value of this? Is this a false statement or a true statement? All right? If it is not Saturday, then there is school. What about Sunday? All right? It could be Sunday. If it's Sunday, it's not Saturday, and there's no school. So therefore, the truth value of this statement is false, okay? Because we want to provide a counterexample. So our counterexample is because it could be Sunday. All right. Now, part B. All right, we want to find the converse of our original conditional statement. So the converse is we want to switch our P and Q. So we want to write Q first. So we would say if there is no school, then it is Saturday. So we're just switching the P and Q. Instead of writing P first, we're going to write Q first. And we switch the if and then. So the converse, if we're switching our P and Q, we're saying if there is no school, then it is Saturday. All right, we switched our P and Q statement. We put Q first, then P. So if Q, then P. If there is no school, then it is Saturday. All right, then we want to determine the truth value of this. Is this true? Is this false? We think about it. All right, then we ask ourselves, what about Sunday? If there is no school, there's no school on Sunday, then it is Saturday. Well, no, it could be Sunday. All right, so the truth value of this is false. All right, because it could be Sunday. Now, contrapositive. So contrapositive, we want to both switch it and negate it. So we want to say the opposite truth value of Q first. So if there is school, that would be negating it and making it come first. If there is school, then it is not Saturday. All right, so we're writing Q negated first, then P negated. So start with Q negated. If there is school, that is Q with the opposite truth value, then it is not Saturday. All right, done. All right, so we switched it and negated it. If there is school, then it is not Saturday. All right, now we want to determine the truth value of this. And we're just thinking of a standard school week, Monday through Friday, all right? I know there could be exceptions. Some schools have Saturday school, and maybe some schools go year-round or have school on Saturday. All right, let's just think of our standard school year. You're not in any trouble. You're not going to Saturday school, okay? So the truth value of this would be true. If there is school, then it is not Saturday, because school only falls on Monday, Tuesday, Wednesday, Thursday, or Friday. So we're going to say that this is true. All right, so I want you guys to try to do number 3 on your own. All right, I'm just going to give you a little bit of assistance, but then I want you to try to do this on your own. So remember, identify your hypothesis. This is your P statement. Your conclusion, that's your Q statement. So if P, then Q. Remember, your inverse is negating P and negating Q. So if not P, then not Q. Your converse is switching them, so if Q, then P. And your contrapositive is switching and negating, so if not Q, then not P. So go ahead and try to come up with these all on your own. Remember to determine the truth value of each statement as well. When you come back, I'll have the answer written on your screen and we'll quickly go through it together. So go ahead and pause your video now. All right, here's the answers to number 3, so let's quickly go through this. So inverse, we're saying if not P, then not Q. So if the temperature is not 25 degrees Fahrenheit, then it is not below freezing. The truth value of this is false, because it could be 20 degrees Fahrenheit. If it's 20 degrees Fahrenheit, the temperature is not 25 degrees, and it is below freezing, okay? So that means it's false. Converse, we switch the Q and P. So if it is below freezing, then the temperature is 25 degrees Fahrenheit. All right, we switched our Q and P. The truth value of this, it's false because it could be 20 degrees Fahrenheit again. And last but not least, the contrapositive. We're switching our Q and P and we're negating them. So we're saying if it is not below freezing, then the temperature is not 25 degrees. Sorry if you can hear my dog barking in the background. All right, this is a true statement, okay? Because if it's not below freezing, then the temperature is not 25 degrees because it has to be above 32 degrees Fahrenheit for it to be freezing. All right, if you have any questions on this, please raise your hand, call me over. Otherwise, let's move on. All right, so now we're going to be talking about biconditional statements. So this is the last type of statement we're going to be talking about today. So what is a biconditional statement? The definition of a biconditional statement is the conjunction of a conditional statement and its converse. All right, so a biconditional statement is the conjunction of a conditional statement and its converse. When we write a biconditional statement in symbolic form, we write it as something that looks like this. So we say if P then Q and if Q then P. And a simpler way of writing it would be like this. So we would say P if and only if Q. All right, so we do an arrow going in both directions. And that little symbol means if and only if. All right, that's a much simpler way than writing out all that. Another important thing to remember about biconditional statements is that biconditional statements are only true when both, all right, so because it's a conjunction, both the conditional and converse have to be true, all right? So biconditional statements are only true when both the conditional and its converse are true because it's a conjunction. All right, let's go through a couple examples. So number 1, we are given the biconditional statement below, and we want to write both the conditional and its converse. And we want to determine the truth value of the biconditional, and we have to explain why or why not. So the first thing we want to do is look at our statement. Two angles are supplementary if and only if the sum of their measures is 180. So let's identify our P and Q. So first, our P is going to be two angles are supplementary. That is our P statement. Our Q statement is the sum of their measures is 180 because we're saying P if and only if Q. So now we have our P and our Q statement. Then we need to remember what is the symbolic form for conditional and converse. So conditional is just if P, then Q. Converse is when we switch them. So if Q, then P. Now let's write out both of these statements. So we're going to write if P, then Q. That is how we write our biconditional statement as a conditional statement. We write it in if-then form. So we would say if two angles are supplementary, then, and then we write Q. So then the sum of their measures is 180 degrees. all right? I don't have the degree symbol here, so I'm just going to write out the word degrees. There's our conditional statement. Now we want to write the converse. So we're going to say, if Q, then P, all right? So we start by writing if Q. So we look at our Q as our green statement. So if the sum of their measures is 180 degrees, then we say our P statement. So then two angles are supplementary. Now we want to determine the truth value of this. So we need to look at the truth value of our conditional statement and the truth value of our converse. We want to ask ourselves first, is our conditional statement true? If two angles are supplementary, then the sum of their measures is 180 degrees. Well, I think this is a true statement, right? This is true. If two angles are supplementary, then the sum of their measures is 180 degrees. Next, we want to look at our converse. So, is this statement true? If the sum of their measures is 180 degrees, then two angles are supplementary. This is a true statement as well. All right, so with biconditional statements, both of them have to be true for the biconditional statement to be true. So the truth value of our biconditional statement, two angles are supplementary if and only if the sum of their measures is 180 degrees, would be true. All right, because both the conditional and the converse are true. All right, so I want you guys to try number 3 on your own. Our statement is x squared equals 25 if and only if x equals 5. All right, so write the conditional of this. Well, first identify your P and Q, write the conditional, write the converse, then determine the truth value of the biconditional statement. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten something that looks like this. So your conditional statement should be, if x squared equals 25, that's our P, then x equals 5, that's our Q. So if P, then Q, our conditional statement. Now our converse, if Q, then P, so we switch them around. If x equals 5, then x squared equals 25. All right, then we want to look at the truth value of both of these statements. So we look at our conditional. If x squared equals 25, then x equals 5. All right, this is a false statement because x could equal negative 5. It's not necessarily has to equal positive 5. So this is false. Our converse, if x equals 5, then x squared equals 25. That is a true statement. All right, but because it is a conjunction, both of these have to be true in order for the biconditional statement to be true. So because one of them is false, we say the whole thing is false because the conditional is false, all right, because x could be negative 5. All right, if you have any questions on this, please raise your hand, call me over so I can help you out. Otherwise, let's move on. All right, so the very last page of your notes is a little graphic organizer to help you organize all of your compound and conditional statements. So it's kind of summarizing everything we've learned about compound and conditional statements so far this chapter. What I want you to do is try to fill this in on your own as much as you can, all right? Be sure to especially try to fill in these boxes, and what I want you to do is put the symbolic notation in these boxes. So, like for conditional statement, if P, then Q. We put a P arrow Q, all right, and all the ones we learned today, plus the ones for conjunction and disjunction, all right? Those are really, really important. Then I want you to try to fill in these boxes too, using P and Q here, using P and Q here for your conditional ones, all right? Do your best to fill this in. Pause your video. When you come back, I'll have all the answers for all of these written on your screen so you can check your answers and make sure you filled this in right. All right, so go ahead and pause your video now and try to quickly fill out this last page. All right, so conjunctions and disjunctions. Important thing to remember is our symbolic notation for this. So we say P and Q. Now for P and Q, we look at our P and Q statement, so vertical angles are congruent. And because it's a conjunction, we use the word and. 15 is a prime number. All right. Now this is false because 15 is not a prime number. All right. And both of them have to be true in order for the whole thing to be true because of that word and because it's a conjunction. Now disjunction, P or Q. So vertical angles are congruent or 15 is a prime number. This is true because with disjunctions, only one of them has to be true for the whole thing to be true. And vertical angles are congruent. That is true. All right? So that's why the truth value of this disjunction is true. All right, next reviewing our conditional statements that we've learned today. All right, so conditional, if P, then Q. So if it is St. Patrick's Day, then it is March. And this is a true statement. Inverse, we say not P. If not P, then not Q. So if it is not St. Patrick's Day, then it is not March. All right, this is false. It could be March 2nd or March 13th. All right, not necessarily St. Patrick's Day. Then we've got our converse. So converse, we switch P and Q. So if Q, then P. If it is March, then it is St. Patrick's Day. So if Q, then P. This is false because once again, it could be any other day in March besides St. Patrick's Day. Contrapositive. If not Q, then not P. So we switch them and negate them. If it is not March, so negating Q. If it is not March, then it is not St. Patrick's Day. All right, this is a true statement because St. Patrick's Day only falls in March. So if it's not March, it can't be St. Patrick's Day. And last but not least, our biconditional statement. P if and only if Q. So it is St. Patrick's Day, which is our P statement, if and only if it is March, our Q statement. All right, and now this is false because our converse is false. So we had to go back and look at our conditional statement, all right, which we know was true, and then we look at our converse, which we found out to be false. Now both of them have to be true because a biconditional statement is a conjunction, all right? So because one of them is false, the whole thing is false. All right, so I hope you learned a thing or two today about conditional statements and biconditional statements, and you're able to summarize that all up in a nice graphic organizer for you on all your logic statements. If you have any questions, please feel free to call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day.